So in this video I want to introduce you to the idea of the antiderivative, or as it's more commonly called, the integral. And thus far in calculus we've learned how to prove derivatives with our limits. We've learned all the different rules how to take derivatives of different functions. We've learned a lot of different applications and things we can do with it. But now we're going the other direction. We'll be given a function and we'll have to figure out what is the function that this is the derivative of. So it's going to be an inverse of a derivative. We're really undoing a derivative here. So just kind of to help get our minds around what we mean by an inverse, if you're not certain, an inverse is simply like multiplication and division undoing each other. If I have 4, if I divide it by 2, that equals 2. Well, if I multiply by 2, that equals 4 again. So multiplication and division are inverses of one another. We're going to apply that same idea, only we're going to be taking derivatives and antiderivatives. So if I say that the derivative with respect to x of x squared is equal to 2x, well, the antiderivative of 2x will be x squared. And just to introduce you to the notation, we use this. It's known as the integral of 2x, and it's with respect to x, so dx. What will this equal? Well, we know it's x squared. However, there's always some arbitrary constant plus c, and that's because the derivative of x squared is 2x. The derivative of x squared plus 4 is still 2x because the derivative of a constant is just 0. So when we take an antiderivative or an integral, there's going to be an infinite number of solutions because you have a plus c that could be any arbitrary constant. And we'll see different examples where we'll be solving for c and other things. So, you know, we use integrals in a lot of different ways, and really the purpose and intent for this video is just to introduce you with the idea and the notation. So to go over some of our basic rules, a derivative is an inverse of an integral. So our integral rules come straight out of our derivative rules. And integrals are more difficult because we don't have rules straightforward for them. It's really a game of trying to write an integral in a form that we know how to integrate. So some of our basic rules you need to know. If we know that the derivative with respect to x of x to some power n is equal to nx to the n minus 1. What does that mean if we have the integral of x to some power n? Since we're undoing a derivative, that's going to be x to the n plus 1 power divided by n plus 1, and then plus some constant c. And you know, it makes sense. If we take the derivative of this expression, we'd multiply n plus 1, which cancels with the denominator, drop the power, c goes to 0, and we're left with just x to the n. So this is kind of our basic power rule for integrals. And just like with derivatives, how we could split a sum or difference. If we had the derivative with respect to x of x squared minus 4x, we could write that as the derivative with respect to x of x squared minus the derivative with respect to x of 4x. And we can do the same thing with integrals. So if, say for instance, we have the integral of x squared minus 3 dx, we can split that into the integral of x squared dx minus the integral of 3 dx. And that will simply be x to the third over 3, because we add 1 to the power, divide by the new power, minus 3x, because 3 is really x to the 0. That becomes x to the first divided by 1, plus some arbitrary constant c. And we see, as we go along with integrals, you'll get really comfortable with these basic rules, and we dive into deeper rules of how to rewrite things. But one final thing I want to touch on is that these rules are coming straight out of our derivative rules, so the same things apply when we're dealing with our trig functions and other transcendental functions. We know that the derivative with respect to x of the sine of x is equal to the cosine of x. Well, the integral of the cosine of x dx, well, that's going to equal the sine of x plus c. So I hope this kind of introduced you to the idea and the concept behind it, and as we move forward we'll see we use integrals for a lot of different things. It's probably the most widely used and most significant mathematical operation as we go into physical sciences, natural sciences, financial mathematics. It's very, very useful in a wide variety of ways. So I hope this video helped you understand and get acquainted with what the integral or antiderivative is.